This course is designed for the National Institute of Standards and Technology, NIST, National Initiative for Cybersecurity Education, NICE Workforce, Roles Systems Developer, Software Developer, and Information Systems Security Developer, and its objectives align with the Department of Defense, DOD Enterprise DevSecOps Reference Design Guidelines. Upon successful completion of this course, you will have the knowledge and skills required to meet compliance requirements while developing a DevSecOps mindset, including using tools in the development stage to help convert requirements into source code, and identifying and mitigating the most common infrastructure as code IaaC vulnerabilities, including excessive privileges or capabilities, misconfigured network filtering, and missing encryption. You are a systems developer faced with the task of implementing infrastructure as code, IaaC. Part of that task is ensuring that this implementation meets compliance requirements and follows industry best practices. You decide to access your company intranet resources to review IaaC, the best practices surrounding this implementation, and mitigation techniques. Click IaaC Review to learn more. Infrastructure as Code, IaaC, refers to using configuration files that are processed by tools to provision and manage infrastructure, such as virtual machines, VMs, containers, virtual private networks, VPNs, and so on. Such configuration files describe the parameters of the infrastructure and are called templates. Because templates can be processed automatically, are plain text files, and can be stored in source code repositories, handling templates is very similar to handling source code, hence the term infrastructure as code. Importantly, IaaC also shifts responsibilities for provisioning, configuring, and securing infrastructure used by applications from system administrators to developers. Your boss comes into your office and looks at your monitor.
Researching IaaC. Good. Adopting the IaaC approach provides multiple benefits.
You write down what she says in your notebook.
It reduces costs by reducing the amount of human labor necessary. Automating infrastructure deployment and management means fewer person-hours required for these tasks. It increases development speed by automating infrastructure provisioning and management tasks. Writing IaaC configuration files can also be easier than manually deploying comparable infrastructure. In addition to helping attain schedule and budget goals, IaaC enables the practice of immutable infrastructure. The entire infrastructure can be quickly and easily redeployed with the latest updates installed rather than having to update individual systems. Adopting this approach reduces the potential for issues associated with misconfiguration of individual deployments and human error. All environments created from the same template are identical. Likewise, IaaC simplifies versioning of infrastructure configurations. The same version control systems that are used for source code can also be used for IaaC templates, making it possible to roll back to earlier versions, create forks, or perform other versioning operations on infrastructure configurations with ease, and to manage infrastructure configuration alongside code running on that infrastructure. And it improves recovery capabilities by making it quick and easy to redeploy infrastructure in the event of failure. Other benefits include the simplification of testing by making it easy to create testing environments that are identical to or very closely resemble production environments. Finally, adopting the IaaC approach simplifies compliance audits. Auditing IaaC configuration files, version control changes, and logs is generally easier than auditing deployed infrastructure and its accompanying documentation.
Now click Best Practices. As your boss takes a breath, you turn to a blank page in your notebook.
That's great information. Thank you. I can incorporate those benefits into these 4 best practices. Follow policy and industry standards, follow DevSecOps processes, scan IaaC templates on commit, and monitor cloud infrastructure.
Click Policy and Standards to learn more about this best practice. Follow the organization's existing policies for defining infrastructure as code templates. In some cases, there may be additional applicable standards or compliance requirements that are specific to the project that a template is used for. Policies and standards, as well as functional requirements, should determine the configuration choices in IaaC templates. For example, if the organization has policies regarding the use of cryptography for protecting data at rest, then templates should enable sufficiently strong encryption for any cloud storage they create. Similarly, authentication, credential, and cryptographic key strength are also likely to be determined by the organization's existing policies. Click DevSecOps Processes to learn more about this best practice. Infrastructure as Code allows applying DevSecOps processes to the templates used to create and manage infrastructure. Because templates are plain text files that are managed using the same versioning technologies as source code files, DevSecOps processes largely involve automation of security activities, such as testing and scanning, to facilitate rapid development and updates. While the exact DevSecOps processes used are different for different organizations and projects, these existing automated security activities, including testing and vulnerability scanning, can be adapted to infrastructure as code templates, although additional specialized tools are likely to be required. Click Scan IaaC Templates to learn more about this best practice. One particularly useful best practice is to scan infrastructure as code templates for vulnerabilities when committing them to code repositories. This practice is particularly effective at preventing vulnerabilities because in DevSecOps processes, templates are processed after being committed to code repositories. Therefore, scanning them when committing will result in templates always having been scanned before they are used to provision or manage any infrastructure. The scanner will be able to detect some issues in templates before these issues cause any actual exploitable vulnerabilities. While automatic scanning of templates is a very effective best practice for preventing low-hanging fruit vulnerabilities, keep in mind that the results of scanning are only as good as the scanner and are therefore not perfect. Different organizations and projects will have different DevSecOps processes in place, and most likely there will be additional testing and vulnerability scanning in the DevSecOps pipeline, such as regular vulnerability scanning of the deployed infrastructure. These existing DevSecOps activities should be applied to both infrastructure as code templates and the resulting infrastructure whenever appropriate. Click Cloud Infrastructure to learn more about this best practice. When practicing DevSecOps, you should monitor infrastructure for signs of compromise, such as spikes in resource usage or unusual access patterns. The individuals responsible for monitoring the infrastructure are likely to be different than the developers that write infrastructure as code templates. Nevertheless, processes for monitoring the usage and access to the resources allocated by the templates need to be implemented. Monitoring the infrastructure provisioned by infrastructure as code templates can help detect, respond to, and minimize the impact of successful attacks. One of the most common results of successful attacks on infrastructure is attackers using the compromised systems to generate cryptocurrencies. Generating cryptocurrencies uses a lot of computational resources, much more so than typical workloads, and attackers often provision additional resources if they can. Both patterns can be easily detected by monitoring resource usage. Another common attack impact is caused by attackers using compromised resources to execute denial of service, DOS attacks. Denial of service attacks usually consume a large amount of bandwidth, which is also something that can be easily detected by monitoring resource usage. Besides generating cryptocurrency and executing denial-of-service attacks, attackers may also be interested in stealing the information stored by the systems, in which case abnormal access patterns may become apparent, especially if the amount of exfiltrated data is large. However, abnormal access patterns are generally harder to notice and thus require more attention than monitoring for abnormal resource usage. If any usage or access anomalies are detected, appropriate incident response procedures as defined by the organization should be carried out. Now click Mitigation Techniques. Seven common IaaC vulnerabilities to avoid are hard-coded secrets, excessive privileges or capabilities, TLS misconfiguration, misconfigured network filtering, missing encryption, exposed storage, and missing logging. Click each type of vulnerability to learn mitigation techniques for each type of vulnerability, and then continue. One of the biggest security vulnerability types associated with IaaC is hard-coded secrets. These are cryptographic keys or authentication credentials that are embedded in IaaC configuration files in plain text format. Anyone that retrieves a copy of these configuration files will be able to view the secrets. Click the hard-coded cryptographic key or the authentication credential to learn more and then continue. Hard-coding cryptographic keys into configuration files is a serious vulnerability that largely defeats the purpose of using encryption. An attacker that retrieves a copy of cryptographic keys can use the keys to defeat encryption, though the attacker will also need to gain access to the encrypted data as well. Secure key management procedures should be followed instead of hard-coding keys into configuration files. Cloud providers typically provide key management services that may be acceptable for your application's policy and compliance requirements. Other types of hard-coded secrets include authentication credentials, which are often the credentials used by IaaC tools to authenticate with a cloud provider and provision resources. An attacker that gets a copy of these credentials will be able to create their own workloads at your organization's expense. This scenario is frequently abused to generate digital currency using the maximum available computational resources at considerable cost to the organization. Other types of authentication credentials might also be present, such as database access credentials or private keys. Compromise of any infrastructure authentication credentials is likely to lead to disastrous consequences. Infrastructure as code tools need authentication credentials to be able to function. However, embedding these credentials directly into configuration files creates a hard-coded secrets vulnerability. The secure solution is to use features for managing credentials provided by the platform, or to use variables in configuration files instead of actual credentials. Different tools provide different options for setting values of variables, including entering values at runtime when the configuration file is processed, using environment variables, or storing the contents of the variables in additional files. While it is often possible to supply values for variables as command line arguments, this approach is not acceptable for passing secrets, because command line arguments can be viewed in the system process list. In general, when setting values of variables that contain secrets, make sure the secrets are adequately protected according to your organization's policies, rather than simply shifting the hard-coded secrets vulnerability to another location. For example, do not just create another configuration file that assigns authentication credentials to variables. In this example, authentication credentials used to provision resources from a cloud service provider, CSP, are hard-coded into the template. Anyone that can view this template will be able to provision resources at the expense of the organization. Click inside the code window to see the mitigation. In this example, authentication credentials used to provision resources from a cloud service provider are loaded from an appropriately protected file in the user's home directory.